There are 7 broad types of waste that we're going to talk through. Work in progress, over-engineering, handoffs, task switching, delays, relearning the process, and defects. And as we go through them, you're going to notice that there is at times a reasonable amount of overlap between them, or you may be able to think of a specific example in your projects where multiple types kind of, there's a bit of blurring between them at times. But these general definitions will cover pretty much everything you'll encounter in your projects. Before we begin, a word of warning. Waste is an intrinsic part of projects and processes. Some types of waste are actually there as a result of a deliberate decision you've made. Waste is not a thing that you should be approaching as abhorrent. Like, you shouldn't be thinking, I must remove all waste from my project. Everything needs to be looked at as sort of a cost-benefit analysis. Why is this waste here, and is it more beneficial for it to be here? So first of all, we're going to look at handoffs. So handoffs is the waste involved when a task has to be handed from one worker in a process to another. The new person has to get up to speed in what's actually happening in the process. So the typical example when it comes to software development is the development of a feature. And here we're going to come to that concept of built-in waste. So unless you're having your software project being done by a single individual, where you just give them the requirements, they do all of the design, they do all of the development, all of the testing, and then give you the end result, there's obviously going to be some handoffs. Maybe they're going to start off having a BA do some analysis work, then it gets handed on to the next person, they do the development work, gets handed on to a tester to test it, etc. Every one of those handoffs obviously brings in some waste. And in many cases, we don't want to avoid that. But there are cases where, for instance, you might give someone a task that is too big for them to finish before they go on leave. So at the point they're 80% through the task, it's time for them to go on leave. They need to hand something over to another developer. That developer now needs to come up to speed with the whole process, everything that's gone before, in order to continue just doing that 20% of the work. So when it comes to handoffs, you want to look at your system and work out ways to optimize the amount of handoffs that there are in the system while still getting the benefits of the handoffs that are there. Work in progress. This one is pretty much the most prevalent form of waste, but it's one that's really, really easy to tackle. Work in progress is work that's been partially, or in some cases fully completed, but say not sent live. And until the point that it's sent live and it's sitting on your web page or on your product and the customer can actually engage with it, it's adding literally no value. You've spent all the money potentially, but it hasn't actually given any value. The main example of work in progress is if your software process doesn't have a defined go live step, you can end up with a lot of stuff that even just through inattention, people haven't realized that this thing has not been sent live. You can end up having spent the money and developed the feature, but no one has realized that that feature is not actually generating any form of value. So work in progress, easy one to tackle just by keeping track of the tasks that you've got around and making sure that everything you've done has been properly delivered. Over-engineering, doing more work than was required to achieve a specific outcome. So the heart of beating this form is active cost-benefit analysis of a feature. So a great example for this one is, say you've got yes, that is the next slide. Say you've got a sign-up form that you want to implement on your site. Now, you're trying to collect name, email address, and phone number for people who are trying to purchase from you. And at its face, that's a pretty simple operation. But you might decide, I want to make sure that every email I get is a valid email. Like, I don't want to waste time with people who give me rubbish emails. So you ask your developer to put in place verification that checks the email and makes sure that the email address is valid. And they spend a few hours putting some regular expressions in place so that someone can no longer put in an incorrect email. But had you not done that work, it's entirely possible that 99% of your leads would have actually given you valid email addresses anyway. So you've spent some time to overcome a problem that was never going to be a problem. And premature optimization, Ben talked earlier about the dangers of optimizing before you've actually found that there's a problem. Over-engineering is exactly that. It is it's deciding to go too far before actually dipping a toe in the water and discovering what the actuality is, getting some data into the system to tell you what you need to do. Task switching. This one is a tough one. This is the battle between responsiveness and efficiency. So you've got a developer and they're working on a cool new feature, and they're working on it, and all of a sudden someone sends you an email, a client of yours sends you an email and says, there's a problem, I can't log in, I can't do task X, Y, or Z. And you immediately go, that is a problem. And because the person has contacted you, you're instilled with an urgency. This thing must be dealt with. And often you don't stop to think, is this something that's occurring for everyone? Is this something that actually has more benefit than the thing the developer is currently working on? And you tap the developer on the shoulder and say, please deal with this thing first. The developer dutifully puts aside what they were doing, picks up the new task, resolves it, tries to go back to the next thing. Another email comes in, the cycle can continue. Every single time the developer breaks from what they were doing, there is, I think it's been studied and found to be, 20 minutes of loss as they get themselves out of the mindset that they were in, delve into the new context of the new problem, and then swap back. So every single time you interrupt someone and make them swap from one task to another, you're introducing waste. So you really need to think about, is the problem I'm solving something that could wait a few hours? Is it going to be the end of the world? Or, can I just let them finish out the thing that they're doing and then make the change? Delays. So delays is another one of those types of waste that is not necessarily bad. So delays is the waiting between the end of one process and another. So it's an indirect type of waste with often impact on elapsed time. So say you've got a shared tester working between a variety of projects and you have a developer, they've finished their task. The task is now ready for testing and that shared tester may not be available. That developer finishes their task and now there is a delay whilst we wait for the tester to pick that task up and continue the process. Now that means that feature temporarily becomes work in progress. It also, depending on the nature of it, you have to deal with the amount of time that the feature is not in the market. So there is a cost there. Now delay is something that can be addressed, but at the same time you have to set that against the cost of having a tester who's always ready to pick up the next thing. So there's an optimization to be had there as to how much delay you can literally take out of a system. Relearning the process. So this is needing to get back up to speed on a piece of the system which has not been looked at for a while. Now this is a similar type to task switching in that every time someone has to engage with a piece of your system, particularly a developer, they have to get themselves into the context. It may be something you deal with, like a piece of the system you deal with day in, day out. But for the developer, they may need to understand how it actually works behind the scenes and the broader context. Now, every time they do that, again looking at the registration form, just say you start with your basic registration form and 2 weeks in you decide you want to add a new field. You want to capture someone's address. So the developer goes and implements an address field. They then don't do any work on that for another few weeks and then you decide, oh, I actually want to change the address field or add a suburb to that address field. Back in they go and they have to relearn how that thing works again in order to start working on it again. You do that over the course of 6 months and you've put waste into the system because you've had them engage in this piece of the code again and again. If you had batched all of those up, and this is where you kind of look at how important the feature is right now, if you batch all of the features up and get them to do it once, you've reduced the waste overall because they've just engaged with the system once, done the changes or all of the changes together, put it live, and now they don't have to deal with it again for a while. Defects. This is the fun one. So defects arise in the code itself. So defects can arise for a number of reasons. They can have processes not be followed. You may have had tests or a testing procedure that wasn't followed. A spec may have been misunderstood or not followed. Some people just, you might miss something working across multiple documents, for instance. You don't see a requirement. The spec may have been insufficient or incorrect. Sometimes the people making specs make mistakes. You may have an indirect effect on code that already existed. So you've made a change to this part of the system and it just so turns out that it also affects this part, but you haven't noticed it and now you've got a bug. And then there's just plain old human error. Sometimes people make mistakes when they're doing stuff. So defects, the difficulty with defects is, as Ben said with the NASA example, you can spend infinite amounts of money trying to deal with defects. And defects is one of the big ones where you want to spend enough time and effort to reduce the majority of defects and make it so that if they are going to occur, they're not going to occur in the critical parts of the system. You want people to be able to engage with the most important parts of your system and have the confidence there, but depending on how important those last 10% are, you may test them less frequently. You may just accept that you're going to rely on reports of those issues coming in, and go from there.